this one is working better. Okay, thank you. So good afternoon, everyone, and welcome to my presentation. My name is Mathis Baubriaud. I'm a PhD student in the French Engineering School Central Lyon, and under the supervision of Spear Building Solutions, a company involved in construction projects in the tertiary sector. Today, I will present my paper entitled Accelerating Indoor Construction Progress Monitoring with Synthetic Data-Powered Deep Learning. I think we've all heard of those technologies before, and today you'll see a concrete example on how we can use them. Let's dive in. Progress monitoring of construction site is essential because it gives the manager the information needed to act quickly and wisely. Interior building environment can be even more challenging because of the interdependence of tasks and the really detailed environment. So as you can see on this short clip, this is the type of environment we are dealing with. And lastly, existing solutions tend to be expensive, require manual data entry, and lack real-time applications. These considerations led to the following motivations for our research. First, image analysis has seen a significant improvements in terms of hardware and software levels. We know that deep learning techniques excels at many computer vision tasks, but they rely heavily on large, high-quality training datasets that are really difficult to obtain. Building information modeling is becoming increasingly prevalent in the construction industry, but it's really costly to maintain. Therefore, it is crucial to capitalize on the data it generates to enhance its profitability. Photorealistic simulations is becoming more and more close to the reality in such way that it can be used for real-world application nowadays. Also, the software acceptance and hardware limitations are less present than before. So the potential of BIM models combined with computer graphics software has not yet been fully explored and thus needed to be evaluated. The imagined method is simple. We start by a BIM model created by experts on Autodesk Revit, and we directly export it to NVIDIA ISARC Sim through a plugin. We then apply colors, textures, and lighting to the 3D model, and we also import every equipment 3D model when available. We then simulate a virtual camera targeting a low-end camera for better representation of the real world. And we simulate every lens imperfection we can have on the camera. Then a route is mapped out inside the building, alternating the viewpoints and capturing each relevant scene from different perspectives. And lastly, we generate the ground truth instance mask segmentation by filtering the elements by their IFC IDs. And we then translate the RGB semantic data into an annotation format for model training. So we carried out this process for 3 construction projects, one 8-story office building, university laboratory, and a brand new site for a business school. It resulted in the dataset we called MEP seg, containing more than 8,000 images with 13 classes of the MEP equipment represented. Additionally, and for evaluation, we collected a real dataset containing 270 images we manually labeled, and we choose YOLO V8 seg model for a baseline to compare transfer learning performance with pre-trained weights on the the generic COCO dataset, pre-trained weights on our MEP seg synthetic dataset, and also an additional testing with a mix of synthetic and real images. So here is a quick review of inference results on a video of our model. And performance shows that using synthetic pre-trained model is very effective compared by using a generic COCO model you can find publicly. And additionally, we also tested using a model pre-trained already on COCO, but by mixing data sets with only 10% real images and the other images were synthetic. And you can see that you only need a really small amount of real images to perform very well on precision, for example. And so it can be used very effectively. My company is also working with a startup company to implement augmented reality on construction sites to visualize BIM model overlaid with reality in real time. The previously segmentation model train has been designed to be put into embedded device like this. And so research is underway to directly compare as-built and as-planned work inside the work site. The workflow imagined has been described here on the right. So we first start by capturing an image using the webcam of the headset. And we compute the same point of view inside the BIM model. We then put our image into the segmentation model to get a first prediction mask. And we compute the same, the ground truth segmentation mask using the BIM model view. And then the superposition of the two can give us a discrepancy mask, which allows us to compare what has been built and what has been planned. Conclusion, I would like to thank all the contributors of this project, so SPI, NextBIM, Central Lyon, and the LIRIS laboratory. We invite you to contact us if you want any details on this research, and I will be available at the end of the presentation for any questions. Thank you.